morning, everyone. Hello and welcome to today OpenShift Coffee Break with my dear colleague, co-guest Jafar. Good morning, Jafar.
Hello, everyone. I'm Fabio. Hi, Christophe.
We are
Hello.
going to hello. Christophe is our guest today. I will give him the opportunity to present himself, so I will not add anything else. Please, Christophe, could you introduce yourself and would like to obviously, yeah, having
So good
our
morning. Let's start with the coffee
coffee.
together.
Let's have a sip before.
As always, we are open to all kinds of coffee. So Italian
Yeah.
coffee, American coffee, Turkish coffee, whatever you want. So please, Christophe.
So I like my coffee cold and with cream. So I'm really bizarre. So I'm Christophe de Dinechin, and I'm working on a product called OpenShift Sandboxed Containers that we are going to discuss today. That's the OpenShift implementation of an upstream project called Kata Containers. I hope that today we'll also have a chance to discuss about some further applications down the road, like confidential containers. And otherwise, I've been working in the past in virtualization, 3D graphics, compilers, and operating systems. So that's essentially my background.
Okay,
Not
cool.
all open source, by the way, unfortunately.
Great.
That's okay. That's okay. We'll all have some not open source past
Yeah.
behind us.
It's never
That's
late
okay.
to the good side.
No, I've always done open source since a very long time, but sometimes I was doing open source on the side and then had my. So, for instance, in a very long time ago, I did the first port of Emacs on macOS 10. Back when it was called Rhapsody, I did the first graphical port.
So, Kata Containers, something related to any martial arts, or do you want
Yeah,
to provide
so
us?
actually you have to be careful about what you're talking about. I saw someone on Twitter was saying that he read about Kafka containers. So Kafka containers is a very different thing. It's when, if your containers are too fast, then you have this option of sending a form in triplicate by fax to your cluster operator, and then he will start your container within 6 months. So that's a different product. Kata Containers is the idea of running containers inside virtual machines to provide a bit additional isolation. Let you, for instance, configure your kernel to your taste, run things as root without having risk for your host, and these kind of things. So this is really a way to exploit lightweight virtual machines. It's a bit counterintuitive because if you remember, initially containers were seen as, oh, that's to avoid virtual machines because virtual machines are heavyweight.
Yeah, and
But
provide isolation as well.
yeah, so the problem with containers is that they run in the host operating system and exploit its resources, exploit whatever isolation features it gives. But then people start thinking, oh yeah, but I can bypass that. For instance, intentionally in the case of privileged containers, which is used often, for instance, to install software on the host or do things like that. And sometimes you have no other choice. For example, if you want to access a physical device, like, I don't know, an SI or unique network interface card or these kind of things, sometimes you need at least part of the configuration to be done using privileged software. And so with Kata Containers, the idea is that you can run this kind of software in its own virtual machine. And that's now feasible easily thanks to Moore's law, because something that 10 years ago made little sense, today we have more resources and so on. So that's something that we can afford. And now you can, for instance, attach a physical device to your VM and let the software inside control that physical device directly while still having isolation enforced by the IO, MMU, and so on. So this gives you additional possibilities for what you can do with containers.
And so just to clarify how this is executed, so You said it allows you to run pods in VMs, but do you mean it's going to run the pod as a VM? Is there like a one-to-one mapping, or each pod turns into a VM? Is that correct?
So exactly. So essentially, the unit corresponding to the VM is the pod, and the rest of the deployment is relatively similar. We use some features like virtual-OFS to expose the host file system to that virtual machine, so that, for instance, you can download your container image on the host and do, have the overlays, etc. And then that's transferred to the guest, and the guest sees the file system, that part of the file system of the host in its own file system. You can also attach things like block devices. You can have other options for how you connect to your storage. The networking, same thing. You have several options, but you can go through turn-tap devices, etc. So there are various ways to connect to the enclosing networking. But then you have your own network, and you can have additional capabilities, for instance, compared to what would be safe in the host.
Okay.
Christophe,
Yeah. Go ahead.
there is always, as you mentioned before, there is always been a great debate on the topic containers versus virtual machine. Now we are bringing the concept of virtual machine on OpenShift. Can you explain us better when? Actually, before, which is the main difference between having virtual machine and sandboxed container, or sorry, Kata Containers, which is a virtual machine in OpenShift Sandboxed Container, and why I should use one of these?
Yeah.
Yes.
And maybe to expand on that. So, for example, the difference between Kata Containers and using something like KubeVirt, which is also a VM inside, a pod as a VM, but what's like the difference, and why is there this new initiative?
So that's a very good question. The idea of Kata Containers is really to have virtual machines in the context of the containers ecosystem. So in other words, you're really running containers, whereas in the case of KubeVirt, you're really running virtual machines, and you can run, for instance, Windows virtual machines, but you're orchestrating them with the OpenShift or Kubernetes execution environment. And so that's the main difference, is that in one case, you're really running containers. That's the case for Kata Containers. And you happen to run them in virtual machines, but that's sort of an implementation detail. Whereas in the case of KubeVirt, you're really interested in running a virtual machine as a virtual machine and to use its benefit. So if it's okay for me to share a screen, I have a node slide deck.
Mm-hmm.
I'm not sure if it's public, so in the sense I'm not sure I can share the link of it, but let me try to.
Just if you share the screen,
Yes.
You should be able to do it, yeah.
Understand better.
Okay.
So does it work?
Yes, perfect.
Yes, that's perfect.
So this slide deck is a bit outdated because it dates back from a presentation I gave at DevConf in 2021, devconf.cz. So, but that's really an overview of what we are doing here. And so essentially, what I just told you is what is shown on this slide here, where we are trying to really benefit from the container ecosystem. And that means a new architecture for application that is scalable, is more modern, etc. You can provision components very easily. You can do software composition. You have all the benefits of dynamic and automated orchestration. In a recent coffee break about Tecton, there was this idea that you can really automate practically anything with OpenShift, and I think that's very true. But at the same time, we want to get some of the benefits of virtual machines, and that includes kernel tuning, configuration, hardware-enforced isolation with things like the IOMMU, etc., and that includes isolated access to devices. And in the future, and that's the confidential containers approach, we can benefit from things like memory encryption, where you can completely hide your guest memory from the host. So that's essentially the kind of benefits that we can get from doing things this way. So I forgot to answer one part of the question, I'm sorry. And that's the question about who benefits from this. And so some of the markets that we see having, where there is some traction for this, include either markets where you want to benefit from the isolation for hardware containment, and that includes, for instance, the telco ecosystem, this kind of environments, or when you want to have isolation for legal or various reasons, and that includes banking and this kind of environments. So these are the two big finance or this kind of things. These are the two areas where we see traction first.
Okay,
I suspect this will.
So please go ahead. No.
I suspect this will become more commonplace in the future as the technology matures and the relative cost of running a VM decreases. So there are many things that you may want to put in VMs further down the road. That's a trend you see, for instance, in OpenShift 4 even now. We have these requirements about enforcing SC-Linux, enforcing various slightly more restrictive policies. There is this trend that we are trying to secure things more over time. And so I suspect that in the future, Kata containers will be used more often because of that.
Let me see if I understood well, or could we say that Kata containers are provided as a sort of another runtime, so you can leverage all the tools that we already have on OpenShift, like the GitOps one, so image one, so on and so forth. So from developers' perspective, you don't lose a lot of features that probably you miss when you use just basic virtualization. Is that
exactly? So,
okay.
So if you know a little bit how Kubernetes and OpenShift run inside, there is this thing called the runtime that you just mentioned, and that's essentially the part that is in charge of managing the containers while they run. And so the historical one is called runC. There is one called crun that is more efficient. It's rewritten in C. It's much smaller, much faster, uses less resources. So that's likely to become more commonplace in the future. And Kata has its own runtime that will take the OCI commands and convert that into operations like, for instance, when you say creating a pod, it's going to start a VM. And when you say create a container, it's going to forward that request to an agent running inside a VM in order to create the container there. So yes, it's a runtime.
Okay, cool, thanks.
Oh, this seems very nice in terms of, I would say, architecture and the type of features that it can add. But do you have maybe a demo that you could show us so we have a better grasp of how things work?
Yes. So this is a cluster here that has Kata containers running, or sorry, OpenShift Sandboxed Containers running. And so maybe I should start with the console. That's probably easier to look at it from a UI perspective. And so the way we actually deploy things is with something called the OpenShift Sandboxed Containers operator that is going to manage the a new runtime class called Kata. And so in order to be able to run a workload, you're going to simply add the runtime class Kata to the workload description. So let me shift to the demo
Christophe,
project.
please, sorry for interrupting. Can you please just zoom in just a little bit, because
yes,
I'm seeing the streaming. Oh, okay, now it's okay, perfect.
But the problem, yeah, I no longer have the menu. So here I'm in this project demo, and I have, for instance, a Jenkins deployment here. And you see that the way it looks is, from your point of view, is practically the same way you would usually. And the YAML, okay, now it's, please wait. So can I make the text of the YAML bigger? Yes, well, if it's bigger, then we don't see much. So can you still see it here?
Yeah, it's fine. It's fine. It's
fine.
So if you look at the spec, so everything looks pretty much like for anything else, with the difference of this runtime class name Kata. And that's really the thing that is going to make the difference. So let me just shut it down and
so is this something that is added automatically by OpenShift, or do you have to tag it, for example, in your deployment YAML or something like that?
Yes, you have to add that to the YAML file. You can do that either manually, or you can have various tools that would do that for you. You can have an admission controller. You can have various things that would, under specific conditions.
Okay.
So. Okay.
So did you want to remove?
Yeah. So why is it complaining it doesn't exist? That's weird. It's there. So why is it complaining that it's not there?
Yeah, right.
Can you go back to?
That's a demo effect. I did that 5 minutes ago.
Are you in the right namespace? Probably.
Yeah. Do OC project?
I'm in demo, I think. Yeah.
Yeah.
Okay. And what do you have in your Jenkins deployment?
Well, so let's check the Jenkins deployment itself.
App Jenkins, okay.
So that's essentially what you have, and oh, I think it's because I think it's because
you changed the name or something?
No, yeah, it's that the one that is running is the one running in Kata. So that's
okay.
That's right. Sorry, I got confused for 2 minutes in my file.
No,
so, and that's precisely what I wanted to show is if you do a diff between Jenkins deployments and Jenkins Kata deployments, that's essentially the difference is the name that I gave to the app so that I can run the two at the same time, and this runtime class name.
Mm-hmm.
And so in order to start it, I can start it from the console or I can start it from here. And that's just, so in that case, I want the Kata one. And that's basically it. Okay, so there is this new warning that appeared in for OpenShift 4.11 that's due to the new security context. But that doesn't prevent that from starting. So
it starts pretty quick.
Yeah, so it's it takes a couple of seconds more to start in some conditions because you need to run a VM, but that's essentially what you need. And then, of course, you can, on top of that, you can add the services or whatever. So it's just, and the service itself doesn't need to change. So.
And so on what runtime does the VM, I mean, what acts as a host for the VM? Is it the node itself? Does the VM run aside? How does it work in terms of...
So I think your question is, where does the VM run?
Yes. Yes.
Okay, so if I look at the nodes that are running here, and so essentially you see that on the roles, this one can run Kata because the operator was deployed on it.
Okay.
So let me start with the installation itself, how you actually deploy that thing. So what you're going to do is, so besides the usual subscription, etc., you're going to install a Kata config like this. And so, well, this one is one that I take directly from some internal builds. So it has this additional element to the spec. But essentially, you're deploying this, and that's going to give you, it's probably better if we watch it.
Yeah. Is it available from the operator hub?
Yes. Yes.
Okay.
So let me go to OpenShift Sandbox. So if you just type Sandboxed here.
Yeah, but you have to enable show default projects, the switch.
Yeah. Thank you.
Okay.
And you see the operator here. And so you see that this is the one that is installed is from my own source.
Your own
but there is one coming from Red Hat that is the official one.
Okay.
And so
does it require anything specific on the node? Any specific configuration? Or it can run on any, so it's running on CoreOS?
So it's running on standard CoreOS. It doesn't need anything specific except being able to run virtual machines, but practically anything they can.
Okay.
And we are working on integrating with the node discovery operator to be able to do more fine-tuning on the kind of machines that you want to deploy this on.
Okay, and so
right now you have to put labels. For instance, if you want to restrict it to a specific set of nodes, when you deploy the operator, you have the ability to say, I want to deploy it on this label, and then.
And does the node need to be like on bare metal, or does it work also if it's a virtual node with nested virtualization or something like that? How does
that work? This one is a bit tricky. So we do most of our developments with nested virtualization, and actually the cluster I just showed you uses nested virtualization, but it's not supported, and it's notably not supported by the various cloud providers. And so that means that at the moment you need to have your nodes on bare metal.
Okay.
We are working on something called peer pods. So if you search peer pods, you're going to find some efforts in this area. And the idea of peer pods is to use the runtime to start a VM not directly by starting, for instance, launching a QEMU instance, as is the case today, but instead by requesting the VM from the cloud provider API.
Nice.
And then you connect to it over a tunnel or something like that. This has been actively worked on for clouds from VMware or others, but it's still work in progress.
Okay, so the VM runs on the host, like the cloud provider
Exactly.
or the hypervisor itself, aside and not as an emulator.
As a nested. Yeah. So it's not so it's no longer nested, and that means you're back in the supported configuration.
Okay.
It's more efficient. It's also necessary for confidential container or similar technologies where nesting is not possible today.
Okay.
So that's a very good question, though. It's at the moment that's one of the weaknesses of the product that we are working actively to fix.
Let's tell better. Is one of the improvement area you're working on.
Yes, yes. Well, it's
Yeah.
really that in the sense that you have to afford bare metal to be able to actually use that correctly today. Now, for the kind of markets that we are thinking about, they would not want to run nested anyway. But
Exactly.
for the more general market, that's clearly a problem.
I think it makes sense because if you look at OpenShift virtualization or things like KubeVirt, that's also something that we would recommend to have like bare metal to run your VMs instead of nested VMs, because you will probably have also performance differences, I guess, if you are using nested virtualization. So for me, it doesn't seem like an issue, especially with everything that we've done to automate installation and upgrades of OpenShift on bare metal instances. It's become pretty easy to manage that in an automated way. So
Yes, and I think that there is implicitly in what you said, there is also a question about performance and resource utilization, etc. And clearly that's a question that many people have.
Mhm.
So there are a number of important differences in how this runs, and so most of the performance impact actually is not due to the overhead of virtualization, but to the fact that we run with a different configuration. To give a simple example, when you run a container today on a machine that has, for instance, 64 CPUs, unless you specifically say to limit resources, etc., it potentially has access to the 64 CPUs, even if it's indirectly. For instance, while it's doing IOs, some of the IO completions might happen anywhere on these 64 CPUs. Now, when you run in Kata Containers, you're going to start a VM, and the VM by default starts with 2 CPUs and very little memory. And then based on the spec that you send, we are going to hot plug additional CPUs, additional memory, and so on. So initially you start with, for instance, 1 CPU and 2 gigs of memory. And if you have something that requires 10 CPUs and 40 gigs of memory on top of this, we're going to hot plug that.
Okay.
Now, let's say that you just added 4 CPUs. Then that means your workload, even if it's not restricted, will never exceed 4 CPUs.
Mm-hmm.
And
Right.
so in terms of risk, you have a better control of resources, because now it's no longer using, running wild potentially, even if you don't put limits. But at the same time, this means that if you just have transient bursts that could actually benefit from extra CPUs, well, they will be clamped by this number of CPUs, and the same with memory. So that's one aspect of performance overhead. Another aspect that is important is that the virtual machine monitor itself, or the virtual machine, requires some resources for itself. So that's why we start the pod with 1 CPU and 2 gigs of memory, just to get started. And you just can't boot Linux if you don't have a minimum set of resources. Now, the overhead we measure, depending on the kernel, tends to be in the 300 megs range per pod. So that's not negligible for very small workloads. If you run just a basic Nginx that itself uses 8 megs, having 300 megs on top of that may not make much sense. Now, the problem in accounting for that is that these 300 megs include, for instance, things like file buffer cache and other things that are really useful for your workload. And again, now they are not shared. when you have a file buffer cache on the host, you share it with everyone else. In that case, it's dedicated to you. So in a sense, it can give you back some of the performance you were losing, for instance, from doing the disk I/O over this this extra Vieta UFS layer. So what this means is that when we do performance studies, we have performance results all over the place. And it's really something it's a completely different configuration. So the performance results you get in few cases can be better. In most cases are worse, but it really varies by how much, for instance, if you do very short network packets, but you do tons of them, that's typically not good in virtualization. And that's true for any kind of virtual machine, not just in Kata containers. So this is really something that you probably want to measure. If you're considering using Kata containers, you should measure to be able to evaluate how big your VM should be, how many resources you need to allocate to the workload, etc. So you need some tuning for that may be completely different from running it on a normal cluster.
Mm-hmm. But yeah, again, I think it's just a question of weighing like the confidentiality, the necessity for the isolation,
Yes.
which may be, I mean, if it's mandatory, then you have there's no question. You just have to correctly, as you say, define the requirements to have a good performance. But if it's not necessary, then you probably just go with the traditional containers, and it will be better
So let's take one example to illustrate what you just said. One of the things we are working on that is not completely working yet because of some issues with how Kata containers deals with huge pages at the moment. But the use case we are working on is supporting a GPDK and SRIOV in these workloads with assigned virtual functions from the host. Now, if you use something like the SIOV plugin in OpenShift today, in theory, it will give you a given card, and you're supposed to access that card and use it. But it's actually relatively complicated from a technical standpoint to guarantee that you will really restrict yourself to that card. If you have the slightest container escape or something, some part that runs a privileged container or whatever, you could actually configure the host the way you want and essentially steal the card from your neighbor or whatever. And so that's a bit of a risk. That's okay if all the workloads that run on your system are yours, but if you start wanting to run some customer workloads alongside with yours, let's say you're in a telco environment near the edge or whatever, there are cases where you want to run workloads that do not belong to you, and you want to make sure that they will not risk damaging your main feature, your main function of transmitting data. So in that case, you can essentially give a card or a virtual function to your virtual machine, run DPDK inside, and so DPDK is user space networking, and so essentially you have no overhead because your DPDK drivers are going to touch the card practically directly. And so in the experiments we did, we had something like less than 2% overhead on some, on tests doing bandwidth tests, etc.
Which will be much higher. But you know that the card is only accessible from that.
But exactly. But now you know that you can't touch any other card. Mm-hmm. So you're essentially using that function. So you are saturating your 10 gig link, but it's yours. It's really only yours. And so that's the good news of where we are going and the kind of features that we mean behind isolation. Now again, this is we had initially scheduled that SIOV would be there for 4.11. It's going to be late. We'll probably have to postpone that to 4.12 because of some unforeseen bugs we discovered in the way huge pages are set up in Kata containers today, which is it's not the right way. So you only have an insufficient number of huge pages in practice, so that doesn't work.
Okay, cool. Christophe, you mentioned more times the word security, workloads isolation, in order to protect or to have an effective, a very secure way to run multi-tenancy workloads across tenants, OpenShift. Is there any new something that you provide us in terms of trends, what you are going to plan on OpenShift Kata containers from security perspective? Mainly when you have to run different workloads on OpenShift in a multi-tenant way.
So one of the things, for instance, that is difficult to do today is if you have tenants that have specific requirements in terms of kernel tuning, for example. So they want to pass specific parameters to the kernel, they want to resize whatever. So if they want to do that, today they need to dedicate nodes to that in a classical OpenShift environment.
Yeah, right.
And their tuning may actually be detrimental for other applications. And so maybe that's uncomfortable and they have to essentially dedicate nodes to this particular tenant and they can't run any other workload on it. So this is the kind of configuration where Kata containers can help, because now you essentially assign this kernel parameters to this specific workload, and only the pods with that workload are going to receive these parameters. This is something that has explicit support in Kata containers in terms of, for instance, you can specify annotations that are dedicated to Kata containers and that will change the boot parameters that you have, or the options that you pass to the VirtaUFS daemon, or this kind of thing. So you have multiple tweaks you can use along the way like this to really configure the kernel the way you want. If you want to run a kernel with traces for debugging purpose, you can do that too. And that's something that you obviously would not want to do on a production system if you had to do it on the host. But if you just do it in your VM, that's fine.
Okay. So you mean you don't have to make the parameters change on the node itself? You can do it inside the VM.
Exactly.
To be ephemeral, and then you can go back to.
Yeah. And that's only this VM, and it doesn't impact anybody else's workload, including other VMs. So you're free to really, that's the same thing, for instance, with Ebpf. Ebpf is something that typically is restricted on normal nodes because there's too much chances of getting it wrong or degrading the performance of others. But you can safely do any kind of send any kind of Ebpf program in your VM. It doesn't impact anyone else. So you're free to get that capability and use it.
So is this all already available, or is it a future implementation?
So that works better upstream at the moment. There are some. Last time I checked, which was 2 months ago, there were some issues with user space versus kernel in our course. And so the end result was that the capabilities were there but could not be named. So you could not actually specify them in the. So there was a bug there. I've not checked recently for that, but for upstream that works.
Okay. And you mentioned there was something about confidentiality. That's part of the question, Fabio. Is that correct?
Yeah, I was just pointing now to the confidential computing, something like that. I read something last day. Is there anything related to confidential computing in the future of Kata containers?
So let me share my screen again. So there is this project derived from Kata Containers called Confidential Containers. And as you can see, it's really active. It became an a CNCF sandbox container, a CNCF sandbox project very recently. So a sandbox project for the CNCF means the beginning of a project that has nothing to do with the sandboxing in OpenShift Sandbox Containers. And so confidential containers will take advantage of the features that are arriving in various CPUs like AMD SCV in Ebpf CPUs or Intel TDX or on S390. There's similar features which allow you to essentially encrypt the memory of your VM so that someone on the host dumping the whole VM memory, for instance, cannot see passwords or other secrets that could be in the VM memory at the moment. So what this allows you now is that in a multi-tenant configuration, you can have two competing tenants on the same system. You know they are not going to be able to read each other's data, which is important, but most important, they don't even need to trust the cloud provider they're running on. So they can essentially run on an untrusted host. Now, these confidential computing technologies are really complicated to set up. One of the things, for instance, that you need is something called Attestation, which lets you validate the workload that you want to run and check that you're running what you expect to run. So essentially, it's a cryptographic exchange that ensures that what you're running is exactly what you want to run. And so this attestation mechanism exists in all the platforms that allow any kind of confidential computing, but it's not implemented the same way. And one of the benefits of confidential containers is that we are trying to hide all this complexity so that essentially you'd get the same benefits as for OpenShift Sandbox Containers, where you just use your existing YAML files, you just add a little line to it. So in that case, that would be a runtime that is confidential. You may have to add some secrets as well. And essentially then your workload deploys safely and cannot be tampered with even by the host. So I gave a talk about this. Let me check. So that's another talk at DevConf again. So you can look it up on the web. So if you look for this talk, there is a YouTube video that talks about it. And so essentially, the problem, as I said, is that the sandboxing that exists today it goes one way. It protects the host from containers, but it doesn't protect the containers from the host. And so if you want to consider your host as hostile, then you need to find a way to protect from that. And that's essentially what confidential computing does. And it's more than just encryption of memory, right? It's also things like making sure you cannot corrupt the state by injecting data in it. And it's also this attestation service that I was telling you, so that you cannot replace your valid Nginx image by some alternate version or whatever.
And so sorry, regarding the attestation, what is it going to check? Like, does it check the YAML resources to verify that?
No, it's really measuring the what you're booting. Let me see. That's here. So essentially, you're measuring that you know on which host you're running and that you know the stack here. We can extend that to also include the container image. But for the container image, we typically use something else, which is cryptographic signatures that already exist. So we don't need more than that for the container itself. But it's really checking that the kernel you run on is trusted and that the hypervisor you run on has not been tampered with.
Okay.
And
so this part, yeah.
So sorry, go ahead.
So the part that we really deal with is this one. That part is supposed to be something that you can validate elsewhere. That's the secure boot and this kind of things that exist already.
Okay.
So and everything is totally transparent in terms of the developer's perspective. So they don't need to do anything in order to exploit or leverage this feature.
So we are trying to make that transparent. It's not very easy. And that's sort of, you can see the complexity of the process here where when you start your VM, you have to, for instance, send a quote. So the attestation agent is going to send a quote based on measurements it did here. That quote itself has to be encrypted with data that includes a nonce so that you can't have replay attacks and so on. And then we are going to use an attestation service that will let some external relying party deliver, for instance, keys that can be used in particular to decrypt the container images. So as you can see, it's a relatively complicated process, and we are moving step by step in this. What you are seeing here is already completely outdated because we no longer rely on Mochi and Scopeo. That was really the first steps in the process, but we use something. There is a lot we can do only with OCI crypt. But the overall process remains the same.
We do have I don't know if you have anything to add related to the confidential content, which is a great news. I just read something about confidential, but I was not aware that as Red Hat we are going to work on this.
So what I showed you here is only upstream. As I said, it's just a sandbox project inside the CNCF. So that's the very beginning of the process. But I'm talking about it here because I want to invite anyone who is interested in these kind of topics to join us and contribute. There's quite a bit of work to do. And as you see, there's already a large team working on it upstream with companies including IBM, Apple, Ant Group, Alibaba, etc. So many of the contributors are actively using Kata containers today in production and want to benefit from these new features. But I see that as a really important use case in the future of Kata containers, and therefore I suspect that probably in 2 years or something like that, we're going to start talking about it in the context of sandbox containers.
Yeah, sure. And there are a lot of domain where probably confidential computing or containers will be really useful. Like I'm involved in some project dealing with cloud sovereign, which is some specific for in EMEA, and data. There are a lot of security levels we need to deal with, and the data in use. So there is data rest, data motion. Data use is one of the area where still there is a lot of things to do. So definitely a great topic. Jafar, I'm seeing finally a question coming from one of our attendees. The name seems to be SH Harris. I don't know how to pronounce it. Sorry.
It's Charles, but it's just a guess. But
it's a story of Sherry's. And the question is it possible to create hardware profiles on compute nodes to advertise where they can support a certain Kata container workload, like 10 gigabit, NIC, GPI, physical RAM, things like that?
Yes, so I quickly alluded to that earlier, that today the option that we give to deploy the operator itself is you set a label on your nodes, and you have to set that manually, and you can use whatever scripts or whatever. Now, the standard way of doing that is with the node discovery operator. and that lets you automate that, but the integration with OpenShift Sandboxed Containers is not complete yet. And so for GPU workloads, so that's typically one case where you want to discover if this given workload has a GPU, this given node has a GPU, and there are folks running dedicated GPUs in Kata Containers. It's a bit tricky to do at the moment, and so we have relatively good instructions on the upstream project on how to do that, and you have to follow these instructions in order to be able to set up both the node and the workload itself to be able to take advantage of the GPU. So this can be done, but it's a bit tricky. Part of the problems described in the upstream documentation are related to which kernel to pick to have GPU support. And that's something that doesn't apply in the case of Sandbox containers because we have only one kernel and it has the features enabled. But the rest of the description does apply.
Okay, and it's maybe unrelated, but in case of GPU for traditional containers, as you mentioned, there's the node discovery operator that automatically adds annotations to the GPU enabled hosts, and there's operators that take advantage of that, like the NUMA operator and such things that allow you to automatically configure the nodes for GPU support and such things. So I would say, I don't know how this relates to the Kata Containers world, but you said that the kernel would have those features enabled anyway.
So essentially, you need to have kernel support for VFIO, and so I'm not sure exactly how this is configured in all cases, but essentially you want to be able to assign a GPU to your guest.
So if this is configured on the host itself, because for example the node discovery operator, if it configures the node with GPU support, then that will be inherited from a Kata container that doesn't change the kernel parameters, I guess. And if we specify
that's not completely sufficient, because you really need to pass specific boot options to the kernel to make sure that you can actually do what you want.
Okay.
And part of the tricks also are that there are some steps that I'm not sure we automate today. Like it's possible that the device, the way you present the device inside the guest doesn't use the same name, so you essentially need to rename it in the guest, and that's part of the work we do. We automated for the SIOV case, where the SIOV device plugin tells the workload what to use by giving a PCI address that is not valid in the guest. So we have to essentially, and that's given through an environment variable. So we essentially have to rewrite the environment to rename the PCI device and replace it with the one that you have to use in the guest.
Okay. All right.
So, as far as I know, that's not automated for GPUs, so you probably have to be a bit to be handholding the workload there.
So, Jafar, I don't know if you have. Is there any more questions from our attendees?
So there's do OpenShift Macbone configs. Okay. What is Macbone?
Yeah, Macbone, probably.
Is it like a misspelling for machine config or?
Oh, machine config maybe?
I don't know. Yeah, maybe it's a misspelling.
Yeah. So
is that machine? Do you mean machine config?
Probably yes.
So let's assume that's the machine config question. When we deploy the operator, so that's a piece that is also on the web. Let me just. So one of the key components or contributions is called the Sandbox Containers operator. Let me share my screen again to show you.
Yeah, so he meant machine config.
Yeah. So that's that is the Sandbox Containers operator source code. So you can look how this works inside. And I don't know where this is written exactly, but essentially this operator, when you're activating it with a Kata config custom resource, as I explained at the beginning, so when you do this this operator deployment, it will actually install software in the various worker nodes. So we use the extension mechanism for that, and essentially we're installing a new copy of our own copy of QEMU plus some other things, so some specific RPMs that get installed in your
nodes.
In your nodes, and so there are reboots involved, and so the machine config operator is dealing with some of these aspects for us.
Okay.
So there is a relationship with the MCO, but that's mostly for these aspect of things. After that, I don't think it gets involved anymore.
Okay. So I think we are up to the hour. Thanks a lot, Christophe, for
Already?
thanks. Yeah, more or less 3
That was
minutes.
short.
Yeah.
Yeah, it went very fast, right? Jafar, do you want to add something more, or?
No, I think it was a pretty interesting topic. Thank you very much, Christophe, for the explanations and the demonstration as well. We've seen from the demo, and although the way things work underneath are very different, it doesn't really make a big change from the user experience perspective. So that's really cool, because just adding the annotation allows you to take benefit to take advantage of that feature. Yeah, but other than that, it was very informative. I wasn't really, I would say, well versed into Kata containers yet, but I think I have a better grasp, and I hope it's the same for our viewers as well. So thanks a lot.
Yeah, just a reminder for our attendees, please join our developer Sandbox. It's a great way to start to play with OpenShift in a very simple way. So you don't need to create an environment. Just a very small one will be provided to you, and you can start to deploy your application. A reminder for next session, next week, we are going to have a guest from MongoDB. We are going to speak about the Red Hat OpenShift database Access, which is a new services, a new feature would allow to connect to application to DB like MongoDB one in a more in a simpler way. And again, thanks a lot for your time. Thanks, Christophe, for the session. It was great. I learned a lot of things, mainly when you spoke about confidential containers. I will take a look at something on Google just to learn more. So thanks a lot again.
Yeah, and please do not forget to check the OpenShift TV schedule. There's a lot of great shows as well happening in the rest of the day. But yeah, again, thanks, Christophe.
Thank you very much, and talk to you soon.
See you soon. Bye. Cheers.
Bye.
Bye.